Okay, so the next step will be quadratic equation. Okay, with quadratic equation, I'll have to teach you a bit, right? Okay, the quadratic equation is written as ax squared plus bx plus c equal to 0. So that is your quadratic equation. The first thing that you need to do is to write it in a standard form. This is the standard form of quadratic equation. Everything is on the left and then it is equated to 0. That is your standard quadratic equation. All right, so this one you are going to solve it by factorizing, right? Going to factorize, and then when you find your factors, you know what to do, right? I've shown you in factorization and I've shown you in simplification, right? So with this, and how do you see that something is a quadratic? You see by the variable with the exponent 2 times bigger than this one, right? So even if I have got a x to the power of 8 plus b x to the power of 4 plus c equal to 0. This is also a quadratic because this exponent is 2 times bigger than that one, right? But if I've got a to the power ax to the power of 3 plus bx maybe to the power of 2 plus c equal to 0, this is not a quadratic. That is not a quadratic because this exponent is not 2 times bigger than that one, right? But if I've got ax plus bx to the power of 1 over 2 plus c equals to 0. This is a quadratic because the exponent here is 1, that one is half of 1. So the exponent of the first variable should be 2 times bigger than the exponent of the second one. You see, so this exponent is 2 times bigger than that one, so we've got a quadratic, right? So to simplify this, I would advise you to use the K method. How do you use a K method here? Like you look at this example, this one right in between. So because it's x to the power of 4, so you have to write this with the x to the power of 4, right? So it's going to be a x to the power of 4 and then b, and then you say plus b x to the power of 4 plus c equal to 0. Then you can see that, okay, this is to the power of 2 again, so that it is remaining that 8, right? Sorry. And then you can see that this exponent, this and this is the same thing, right? So you can let x to the power of 4 be anything. Like I'm using k, right? So I will have what? So I will have a k squared plus b k plus c equal to 0. So now I've got a basic quadratic that I know how to simplify. All right, even here you were supposed to write this one as x to the power of 1 over 2 to the power of 2, because when you multiply this we come back here, and then when you substitute the k, you already again have the same thing. All right, okay, so I'm going to show you in questions that will come on the exams, right? Okay, number 1, if they bring you x squared plus 5 is equals to 6x. All right, you can see it's not in a standard form. Writing it in standard form, you'll get a mark for it. Okay, let me write this in standard form. It's going to be x squared minus 6x plus 5 equal to 0. They'll give me a mark for that because I've written it in a standard form. Then I can factorize my things. All right, so this one's going to be minus 5 and minus 1. All right, so my x will be 5 or my x will be 1. All right, so I'm done with this one. So let's try another one. They're saying 2x minus 4. Is it 2? No, it's 3x minus 4. 3x minus 4. 5x plus 2 equal to 0. So they're saying we are simplifying, we're solving for x, right? So this one is already factorized, right? So just take the first bracket, we equate it to 0, second bracket we equate it to 0, so it's 3x minus 4 is equal to 0, or 5x plus 2 is equal to 0. So this one will be 3x is equals to 4, and then when we divide by 3, our x will be 4 over 3. So let's go to this one. 5x is equals to negative 2, and then I'll divide by 5, and then my x will be negative 2 over 5. So that's it. This one was straightforward. So let's look at another one. Let's look at number 3. Number 3, what are they saying? They're saying that x to the power of 4 plus x to the power of 2. X to the power of 4 plus x to the power of 2 minus 10 equals to 0. Minus 10 equals to 0. So let's look at this one. This exponent is 2 times bigger than that one. So again, it shows us that we're going to have a quadratic. Right? It shows that we're going to have a quadratic. So how are we going to factorize this quadratic? There is 3, sorry. So here is 3. So how are we going to factorize this quadratic? For you, I showed you, you have to say x to the power of 2 to the power of 2 plus 3x to the power of 2 minus 10 equals to 0. Right? So you can let x to the power of 2 be k. Right? So everywhere where I say x to the power of 2, I'm just going to substitute k. So here and there. So it's going to be k squared plus 3k minus 10 equals to 0. Right? Then I can factorize. When I factorize this one, I'm going to have k, and then the factors of this that will give me this is 5 and 2. So this one will be positive, this one will be negative, equal to 0. And then my k will be negative 5, or my k will be 2. Right? And remember, we said x to the power of 2 is our k, right? Therefore, and even it was therefore, so therefore x to the power of 2 is equals to negative 5, or x to the power of 2 is equals to 2. Right? So there is nothing that you can square and get a negative answer, so this one will crush it. And then this one, which number do we square it and get a 2? Which number do we square it and get a 2? So we have to solve this one, which is square root, and then when we introduce square root, it should be plus or minus. So x is equals to plus or minus the square root of 2. There we are. We are done with this one as well. Right? So let's look at another one. It was straightforward, even this one. So this one, the one that we are going to look at is number 4. Number 4, what are they saying? They're saying 4x to the power of 2 over 3. X to the power of 2 over 3. And then plus 3 x to the power of 1 over 3, and then minus 10 equals to 0. Minus 10 equals to 0. All right? Okay. So with this one again, what are they saying? Well, I've got this one and that one. So this one, this exponent is 2 times bigger than that one. If you divide this by 2, you get this one. Right? So this one is our standard, right? So then therefore I'm going to have x to the power of 1 over 3 squared plus 3x to the power of 1 over 3 minus 10 is equals to 0. All right? So I've got the squared, I've got to the power of 1, so I've got a quadratic. So I'm going to let x to the power of 1 over 3 be k. All right? Therefore, I will have k squared plus 3k minus 10 equals to 0. All right? So what do we have here? Again, we've got the same thing that we had somewhere here. All right? So I'm going to factorize k plus 5, and then k minus 2 equals to 0. Therefore, my k will be 3, or my k will be 2. Right? My k will be negative 3, or my k will be 2. Right? Therefore, my k is what? 3 to the power of 1 over 3 is equals to negative 3, or 3 to the power of 1 over 3 is equals to 2. All right? So to simplify this, I will have to put this to the power of 3 to the power of 3. Right? So what will I get? So here is x, sorry. is x. Sorry, I don't know what was I doing there. Okay, so this x is going to be negative 327, or to the power of 3 to the power of 3 to get rid of the 1 over 3, right? So it's going to be 8. This one's going to be 8x is equals to 8. So x, we've got two values of x there. All right, so that is how you find your answers. All right, so that is how you find your answers. Okay, I made a mistake here. It was supposed to be 5, negative 5, right? I don't know where the 3 was coming from. So negative 5 squared is going to be negative 125. I don't know where am I getting the 3. I was just writing 3 everywhere. I don't know where was I getting the 3. This was the 3 that was messing everything to me. Okay, so there is the answer. I'm sure you can see everything is like messed up now, but I've shown you the steps that you have to take. Let's go to the next page. Okay, we're still on quadratic equation, so let's go to let's try number 5. Number 5, they are saying that x plus 3 square root of x, 3 square root of x minus 10 equals to 0. Minus 10 equals to 0. Okay, this one again, you can see I've got the same thing again, but here I need to write this in an exponential form. That's when I can easily use the k method. All right, so to write this, I'm going to write x plus 3 x to the power of 1 over 2 minus 10 equals to 0. I'm starting to make a lot of mistakes. I don't know why. I've been having classes for a very long time. Okay, so this one and this one, you can see that this one is the same as 1 over 2 multiplied by 2. I've shown you before. So this one you can write it x to the power of 1 over 2 to the power of 2 plus 3. Sorry, yes, it's 3. X to the power of 1 over 2 minus 10 equals to 0. Okay, so now I can use again the k method. Let x to the 1 over 2 be k. All right, so I'll have what? I'll have k squared plus 3k minus 10 equals to 0. All right, so when I simplify this, I'm going to have what? I'm going to factorize again. It's k plus 5 and then k minus 2 equals to 0. Therefore my k will be negative 5, or my k will be 2. All right, and then I can substitute back x 1 over 2 is negative 5, or x 1 over 2 is 2. All right, then I can square both sides. All right, square both sides to get rid of the 1 over 2. So it's going to be x is 25, or x is 4. All right, so it's very straightforward. You can all see it's 100% straightforward. Okay, so now let's go to the last example. The last example that they like, number 6. They like to bring something like 2 to the power of 2x minus 6, and then x to 2 to the power of x, and then equals to 60. All right, so there we are. How do I see that I've got a quadratic again? I see that I've got a quadratic because this exponent is 2 times bigger than that one. 2 times bigger than that one. So I'll write it in standard form. 2 to the power of 2x minus 6 multiplied by 2 to the power of x minus 16 equals to 0. Then because this exponent is 2 times bigger than that one, so and the base is the same thing, that means I will have to use the k method again. So this one is going to be 2 to the power of x squared, right? 2 to the power of x, there it is. 6 multiplied by 2 to the power of x minus 16 equals to 0. So this and this, I will use the k method. Let 2 to the power of x be k. All right, so it's going to be k squared minus 6k minus 16 equals to 0. Right, so I can factorize this k equals to 0. I've seen it is 8 and 2. So So the negative will go to the bigger one. There we are. So my k will be 8, or my k will be negative 2. All right. So the k is what? K is 2 to the power of x. 2 to the power of x is 8, or 2 to the power of... Okay, I'm sorry, the network just giving it some problems. Okay, so it's 2 to the power of x equals to negative 2. And then after this, you know that there is no way you can raise 2 to any power and get a negative answer. So this one won't be valid. So this one is 2 to the power of x is the same as 2 to the power of 3. Same base, same exponent. X is equals to 3. Okay, then we are done with quadratic equations, right? So please don't make a mistake. This is how quadratic equation is. So now I'm going to something that people usually mix up with quadratic equations, but I'm sure you guys won't mix it up, because I was supposed to finish with that other one, so I want to come with it now, because I want you to be able to differentiate between this one and the one that we are going on. So I'm going to use it to do it underneath here. Now we've got the exponential equations, right? So let's go to exponential. All right, exponential. Okay, with exponential, you have to remember all the laws of exponent. When we're multiplying something, we add the exponent. When we multiply same base, we add the exponent. When we're dividing same base, we subtract the exponent. Those kind of things, right? You have to remember that, and then you don't have to make any mistake. Okay, so the first one, I've got 4 to the power of x is equals to 8. 4 to the power of x is equals to 8, and then we are solving for x. All right, okay, what you have to do, I know that this is not a prime number. I can write this in a form of prime base. All right, to get the prime, to write this one as a prime with a prime base. So this one is going to be the same as 2 to the power of 2, or to the power of x is equals to 2 to the power of 3. All right, so same base. Okay, let me write this 2 to the power of 2x. This and this will multiply and get 2x, and 2 to the power of 3. So same base, same exponent. 2x is equals to 3. So my x is 3 over 2, because I divided both sides by 3. All right, so this is what you should remember when we are simplifying the exponential equations, right? Okay, so number 2, I've got 0.0625 0.0625 to the power of x is equals to 64. Okay, so what are we supposed to do? We are supposed to do shift factor. We are supposed to write this, then the calculator will give it to you in a fraction form. All right, this base here. So in fraction form is 1 over 16 to the power of x is equals to 64. All right, okay, so we know that 64 is the same as 2 to the power of 6. You can use shift factor, you'll find that, right? So this is the same as 2 to the power of 6, and then here is 1 to the power of x over 16 to the power of x, right? You can take in the exponent, right? So 1 to the power of anything is 1. All right, so at the denominator, I can write 16 with the base of 2. So it's 2 to the power of 4. 2, 4, 8, 16 is 2 to the power of 4 to the power of x. All right, it's equals to 2 to the power of 6. All right, so after this, I'm just gonna write this on top. And remember, when something is in denominator, when you have to write it as a numerator, to have to change sign. So this 2 to the power of x will be 2 to the power of negative 4. X is equals to 2 to the power of 6. Then I can equate the exponent. So 4x is equals to negative 4x is equals to 6. Then I divide by negative 4. I divide by negative 4. Then my x is negative 3 over 2. So that's how we solve for x. All right, so this one is pretty easy. All right, pretty easy and straightforward. All right, so let me get to something that most people mix with quadratic. All right, okay, if I've got 3 to the power of x plus 1, 3 to the power of x plus 1 plus 5 multiplied by 3 to the power of x is equals to 33. right? So most people mix this and this one, right? So I'm going to show you the difference. You see this one and this one, most people mix them up, all right? So this one, you can see that the exponent is 2 times bigger than that one, but this exponent is x and is x, then our variable is x and is x. There's no 2x, all right? So this one is not a quadratic, all right? This one is not a quadratic, don't make that mistake. So with this one, you can revert back to say 3 to the power of x multiplied by 3 to the power of 1 plus 5 to the power of 5 multiplied by 3 to the power of x is equals to 33. All right, you can see that you have got a common factor of 3 to the power of x. So factor out 3 to the power of x, and then here we'll be left with 3 plus, is it plus or minus? It is supposed to be a plus. Okay, 3 plus 5, because it's 1, right? Yes, 3 plus 5 is equals to 33. All right, so after that, what do we have? Okay, we had 2 here, sorry, I was being, okay, we had 2 here, so this is 2 multiplied by 3, okay, 2 multiplied by 3 plus 5, right? We had 2 here, so please, sorry. Okay, so this is 11, 2 multiplied by this is 6 plus this is 11, right? So we can divide by 11, divide by 11, then 3 to the power of x will be 3, right? So same base, same exponent, our x will be 1, all right? Okay, I checked back on the question because I saw that without this being 11, we're not going to be able to factorize. So this is number 3, but I showed you there what you have to do. And what do you see that this is different from that one, all right? Because if I've got x to the power of 2x minus 1 plus x to the power of, let's say plus 1 plus x, yeah, and plus, I'm making a mistake. If I've got 2 to the power of 2x plus 1 and then minus 3 multiplied by 2 to the power of x, maybe even plus 3 equals to 4, all right? Here I can see that I've got a quadratic. Why am I saying I've got a quadratic? Because you see this one is 2 times bigger than that one, all right? We don't look at the numbers. In fact, we look at the variable. This variable is 2 times bigger than that one, so this is a quadratic. But here, because I've got x and x, it's a exponential, all right? So don't make that mistake. Most learners make that mistake, so I'm not expecting you to make that mistake as I have cleared it for you, all right? So let's look at let's look at another one. Okay, let's open another page. Okay, let's look at another one, which is number 4. And what are they saying in number 4? They are saying 27 to the power of 3x plus 1. 27 to the power of 3x plus 1 is the exponent, is equals to 81 to the power of 81 to the power of 2x plus 5. 2x plus 5, all right? Okay, so how are we going to solve this? How are we going to solve this? We have to write this as 3, right? This is the same as 3 to the power of 2 is 9, 3, right? To the power of 3x plus 1 is equals to 81 is the same as what? 81 is the same as 3 to the power of 4. 3 to the power of 4 into 2x plus 5, right? So for the same base, I'm going to equate the exponents, right? This multiplied by this is going to be 9x plus 3 is equals to that, and that's going to be 8x plus 20, right? Then I'm going to take this to the other side, so this 9x minus 8x is equals to 20 minus 3, all right? So x will be end up being 17, all right? So my x is 17. So we are done with this one. It's pretty straightforward as well. Okay, so let's go to the last one, which is number 5. Number 5, they are saying 0.5 to the power of x, the power of x, and then they've given us multiplied by square root of 1 plus 9 over 16 plus 9 over 16 is equals to 100. Okay, so now I'm going to deal with this one. I will add this 2 first. Yes, I'll add the 2 inside the square root and make sure that it's a 1 fraction. Then I will see what will happen, because this one is the same as 1 over 2 to the power of x. And then inside the square root here, if I must subtract this 16 over 16. If I add this, it's going to mean that I'm going to have the square root of 25 over 16. Right? Yes. And then it's equals to 100. Right? Okay, this is not true, it's x. Okay, so I've got this. This square root of 25 is 5 over square root is 4. Right? So I've got 1 over 2 to the power of x being multiplied by 5 over 4 is equals to 100. All right, so I can multiply both sides by 4 over 5, multiply by 4 over 5. Right, so this is going to be 80. So this is 18, and then here I've got 1 over 2 to the power of x. All right, so 2 shift fact, we cannot have a true, so I'm going to use a log. So x is equals to log base 1 over 2, then 80. I don't have a calculator, you punch on a calculator. We'll talk about logs. Okay, when I talk about quadratic equation, I'll also introduce you to logs, because this one is the only way that you can solve for this one is by applying a log. Okay, so let's go to the next one. Okay, now let's look at simultaneous equation. With simultaneous, I'm not going to say much. I'm 100% sure you all know how to solve the simultaneous equation, wherein one equation is quadratic and the other one is linear equation, right? Okay, so with this one, I've got y plus x is equals to 12. Y plus x equals to 12, and then the other equation, they said xy is equals to 14. Equals to 14. 14 minus 3x. All right. Okay, so this is the equation number 1, and then I call this equation number 2. All right. Okay, with this one, it's easy to make y subject to the formula. It's also easy to make x subject to the formula. So it's one choice, right? I can make x subject to the formula, I will be fine. I can make y subject to the formula, I will be fine also. All right. But if I make x subject to the formula, I'll have to substitute y here. If I make y subject to the formula, okay, it's fine. Okay, so I'm choosing to make x subject to or y subject to the formula. So it's going to be, I will have to write it down so that I don't forget. So from equation number 1, which is y plus x is 12, right? I know that it will be y is equals to 12 minus x. All right, so I will have to substitute what I got, which is y is equals to 12 minus x in equation number 2. Right, so wherever I see y, I'm going to substitute this. So it's going to be x into 12 minus x is equals to 14 minus 3x. All right, and then when I expand, it's going to be 12x minus x squared is equals to 14 minus 3x, right? Then I'll take this to the other side, so that x squared will be positive minus 3x minus 12x plus 14 equals to 0. So it's x squared minus 15x plus 14 is 0. So I've got same sign, which is negative, then it's 14 and 1. It's x minus 14 or x minus 1 equals to 0. So my x will be 14 or my x will be 1. All right, so this is my axis for this one. So how do I get a y? I come here. All right, so my y will be 12 minus 14, which is negative 2, or my y will be 12 minus 1, which is 11. So those are my y's and those are my x's. So I'm done with simultaneous. I'm sure all of you can solve simultaneous equation. So let's go to the next one. Okay, let's look at the last one, which is a surd equations. Right? Okay, this one, the tip that I'm going to give you is that whenever you see a surd, a simplifying for a surd, make sure that you isolate the surd, which means you have to put it on the other side of a equal sign, right? It doesn't have to mix with anything, and then get rid of the surd by squaring both sides. All right. Okay, for example, number 1, I've got the square root of x minus 2. X minus 2 is equals to 3. All right. So with this one, all I have to do is to square both sides. So square root of x minus 2, I will square it, is equals to 3. I will square both sides, so it's going to be x minus 2 is equals to 9. Then I can add 2 both. I can take 2 to the other side, x equals to 9 plus 2. So my x will be 11. All right. Okay, so I go to number 2. Number 2, they said square root of x plus 5. Square root of x plus 5 minus x is equals to 3. Minus x is equals to 3. All right. Therefore, I can take this to the other side. So I have square root of x plus 5 is equals to x plus 3. So I've isolated the square root because I couldn't square once the x is out, which is outside the brackets, was on the same side with the my set. So I'm going to square both sides now, right? So I will have x plus 5 is equals to x squared plus 6x plus 9. All right. So take everything to the other side. I'll have x squared plus 6x, and then this one will be minus x, and then plus 9, and then this one will be minus 5 equals to 0. So it's x squared plus 5x plus 4 equals to 0. So when I factorize, it's x plus 4 and x plus 1 equals to 0. All right. And then which means I will have 2 answers. My x will be -4 or my x will be -1, right? After this one, you have to check your answer if your answer will be correct. Okay, let me check my answers now. I have to check my answers. If I put -4 here, to -4 plus this, which will be 1, right? And -4 minus this will be 4. So this and this will be 5. It must not be equal to 3. So this one is not correct, right? But if I put -1 here, it will be 4, it will be 2, and then -1 is be plus, so 2 plus 1 is 3. So this one is correct, and this one is not correct. All right. So the answer is this one, and then you will get a final mark for cancelling out this one, because if you don't cancel it, you will lose 1 mark.